Hello, good day viewers. Still on WAEC 2024 Mathematics Examination Objective Questions. Today we are going to begin with question number 21 down to question number 25. And here is question number 21. We are given a diagram which you can see right here. Let us read the information given. In the diagram above, line MN is parallel to line KL. So let us find them. We have MN here and we have KL here. So these two lines are parallel. No matter where they get to, they will never meet. Then we have line ML and line KN intersect at X. So it means that this line right here, which is a transversal line, and this other transversal line meet at X. The measure of line MN is 12 cm. You can see that right here. This line is 12 cm in length, and the measure of MX is 10 cm. So from M down to X is 10 cm, and the measure of KL is 9 cm. You can see K down to L is 9 cm. If the area of the triangle MXN is 16 cm squared, so what is MXN? MXN, so we are talking about this particular triangle. The area is what? 16 cm squared. We are asked to calculate the area of the triangle LXK. LXK, so we're talking about this particular one. So it is unknown. Let us define it as A. If you observe, these two shapes are similar. Why do I say they are similar? Just observe. We have two parallel lines and a transversal line. These two lines are transversal lines. So if you observe, all of the two shapes have the same interior angles because these two lines are parallel and we have a transversal line here, which implies that this particular angle is equal to this one. Likewise, this angle must be equal to this one, and opposite angles are equal. So all their interior angles are the same. So it implies they are similar shapes. All right. If they are similar, we can use scale factor to find the area of the smaller figure here. Let us start with linear scale factor. What is linear scale factor? We need to find two lines that correspond. We know that this line and this line correspond. So we need to find that value which we can multiply this small value 9 to get 12. So that is our linear scale factor. So let the linear scale factor be something else. Let's call it X, or let me call it Y. So if we should take 9 and multiply by this Y, it will give us 12. That is linear scale factor. Therefore, if we divide both sides by Y, by 9, I mean, it will be 12 divided by 9. So this is our linear scale factor. Then there is what we call area scale factor. If we should find that area scale factor, then multiply by this small area, it will give us the big area, definitely. And we can find that from the linear scale factor. So area scale factor would be y squared, and y squared is 12 divided by 9 whole squared, and 12 divided by 9 squared is 144 divided by 81, because 12 squared is 144 and 9 squared is 81. Therefore, this is our area scale factor. So if we take this area scale factor, we multiply that with our small area A, right? Because I call it A. If we multiply this 144 by our small area divided by 81, it will give us the big area, which is 16. So to find this small area, we can divide both sides by 144 divided by 81, or we can multiply both sides by the reciprocal, all the same. a is equal to 16 multiplied by the reciprocal of this, which is 81 divided by 144. So just take your calculator, take this value, multiply by this, then you divide the result by 144. That will give us 9 exactly. So a is equal to 9 cm squared, and this is the area of that small figure to the top, which is right here. Now let us move on to question number 22. Question number 22 reads, a ladder which is 15 meters long leans against a vertical pole, making an angle of 72 degrees with the horizontal ground. We're asked to calculate correct to one decimal place the distance between the foot of the ladder and the pole. All right, let us make a sketch here. Suppose we have a pole right here. This is the vertical horizontal ground, and we have our ladder which is against this pole. This is our ladder. It forms an angle of 72 degrees with the horizontal ground, and it has a length of 15 meter, right? 15 meter. So we asked to find, correct to one decimal place, the distance between the foot of the ladder and the pole. So we're talking about from this point to this point. Let us call it x. So what is the relationship between the hypotenuse, because this is a right angle triangle. If you observe, this is our right angle, this is the adjacent side, and this is the hypotenuse side. So what is the relationship? It is cosine, because cosine theta is equal to what? Adjacent divided by the hypotenuse. So cos of theta, which is 72 degrees, is equal to the adjacent side, which is x, divided by the hypotenuse, which is 15. Then to find x, we multiply both sides by 15. 15 cosine 72 degrees, and 15 multiplied by cosine of 72 degrees will give us 4.63525, but they said correct to one decimal place, therefore this is equal to 4.6. Is it in meters? Yeah, meters in one decimal place. As simple as that. So this is the solution to question number 22. Let us move on to question number 23. Here is question number 23. We are given a circle and an inscribed figure here. This is a chord, remember? Okay, let me read the question first. In the diagram above, O is the center of the circle, and the measure of OA is 25 cm, and that of AB, A down to B, is 40 cm. We are asked to find the measure of OH. So from the center to this point, which is vertically, it bisects AB. So if you observe, let us pay attention to this one. It is a right angle triangle, because you can see that right here. So since this line bisected AB, it divides the line into two equal parts, making 20 each, right? Because it is 40 in length. So it stated that hypotenuse squared, according to Pythagoras theorem, it stated that hypotenuse squared, which is 25 squared, is equal to the adjacent squared, which is 20 squared, plus the opposite squared, which is not given. Okay, let me just call it OH, as mentioned from the question. So if we make this one the subject, it will be OH whole squared equals 25 squared minus 20 squared. If you don't have calculator, you can use difference of two squares, because this can be factorized as 25 minus 20, then multiply by 25 plus 20. This is the same thing as 25 squared minus 20 squared. And 25 minus 20 will give us 5, multiplied by 25 plus 20 will give us 45. And if you multiply this together, you're going to get 225. Remember, this is OH squared. But we are looking for OH, so you can take square root of both sides. You don't need to add plus or minus because we're talking about length. And square root of 225 is 15. And hence, 15 cm is the length of OH, this side. This is 23. Let's move on to question number 24. Question number 24 reads, given that P is 25 meter on a bearing of 330 degrees from Q, how far south of P is Q? All right, you should know that in bearing, the word from is very important. It indicates where you're going to construct that angle. So this angle 330 degrees will have to be constructed from Q. So let's start with the first point. So assuming we have point Q right here, this is point Q, and in three-figure bearing you have to start from the north clockwise. Remember that this is 90, this is 90, this is 90. So let's keep on adding 90, 90, 90, 180, another 90, that is 270. So we need 60 extra to get to 330. So let me use another color to complete it. This is 60. So the line heading to P is this, something like this. So this is point P. And it stated that from P down to Q is 25 meter, and this is 330 degrees. But this angle, only this angle right here is 60 degrees. Because I told you from this down, this is 270. So we need 60 extra to make it 330. So the question is saying how far south of P is Q? So we're talking about this vertical distance, which is the south of P, till it hit the point horizontally leading to Q, which is this one. So we are looking for this. So you can see we have the hypotenuse, we have the opposite side, and we have an angle of 60 degrees. This is a right angle. And according to the sine ratios, remember that sine of theta is equal to opposite divided by the hypotenuse. So sine of 60 degrees is equal to opposite divided by the hypotenuse, and x is equal to 25 multiplied by sine of 60 degrees. Use your calculator, press this directly, it will give you approximately 21.7 meter, and this is exactly the solution to this problem. Moving on to question number 25. A car valued $600,000 depreciates by 10% each year. What will be the value of the car at the end of 2 years? The value would be initial value multiplied by 1 minus the rate at which it is depreciating, raised to the power of the number of years. So this is equal to, the initial value is 600,000 multiplied by 1 minus the rate is 10%, and 10% is the same thing as 0.1. This is to the power of 2 years, right? To the power of 2. This is 600,000. This is 0.9 to the power of 2. 600,000 multiplied by the whole of this is 0.81. And lastly, we are going to multiply these two values together, and that is $486,000 after 2 years. So from 600,000 to 486,000, you see there's a depreciation in the price or in the value. So this is all we have today. In our next class, we are going to start with question number 26 down to question number 30. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.